Already started recording? Perfect. So hi everyone, we are presenting live at PyCon US 2023, celebrating 20 years of PyCon, and me and Gaurav, we are presenting a poster on UnionML building machine learning microservices and MLOps using UnionML. So we love to share some of the pain points that DevOps engineers and data scientists face on a day-to-day basis, and how UnionML helps bridge some of those gaps and some of those issues that these people face. I'm Shivay, and I've been contributing to UnionML, and with me I have Gaurav. So Gaurav,
So hi everyone, my name is Gaurav. I'm a high schooler from India. I'm super excited to present a poster at PyCon here. Let's start.
Sure. So I like to probably start with one of the biggest gripes that most data scientists have, is that typically as a data scientist, you're writing a lot of Python notebooks, right? It could be a Python notebook, it could be a Python file in a Python like IDE, or it could be like, let's say, an Apache Zeppelin notebook. Now, as a data scientist, if you ask a data scientist that, hey, can you deploy this model that you have just right? They will go bonkers, they'll go angry, like.
Yeah, building machine learning model is pretty easy, and then deploying is the one of the main challenge. Like it's a question of every beginner. Like I can make a model in Jupyter Notebook, but how to deploy it on the web or somewhere else?
Exactly. Yeah. And as a data scientist, they don't want to get involved with DevOps, and similarly, a DevOps engineer does not want to get involved with machine learning at all. So when we talk about MLOps, which is basically bringing the same practices for DevOps that you follow in standard software development, but for machine learning, it's usually the hard case that we see. So UnionML is trying to bridge that gap for data scientists and DevOps engineers to work together and bring in a tooling so that the data scientists can automatically deploy their models that they are writing inside of these Python notebooks, and make it easier for post-production of your model to also then continuously evaluate your model, and then of course if there is any requirement for changing the model into once it goes in production, to manage that very easily with the help of UnionML. So I'd like to kind of first start off with what UnionML does. So UnionML is an open source Python framework that has been built on top of Flyte. So Flyte is an open source machine learning orchestration platform that provides end-to-end workflows, and it can very easily manage on top of something like Kubernetes. So it's built on top of a Kubernetes native environment. And over to you, Gaurav, to probably explain some of the other workflows.
So one of the major problems that UnionML addresses is decreases the complexity of deploying machine learning models into production, and it makes the process a lot smoother. But for example, a machine learning engineer can obviously deploy a model by their own, and the couple of features of UnionML is you can scale up your model or scale up your complete machine learning model and serve anywhere, because you can deploy your model on Fast API or Robin or anything.
Yeah. So I like to probably start with one use case, right? So in an entire machine learning workflow, you typically start with training your data, right? So your data is the king, and the most important is that how do you find your data, right? So typically inside of a machine learning workflow, you'll have your data set in a CSV file format, but normally your data will not always be there in a CSV format. Your data might be there in a data store existing in a SQL database or a NoSQL database, or probably in Snowflake or any other data format. So as the first step, you will have to do the data conversion, where you take your data in the SQL format and convert it into a CSV format, so that you could use it with things like pandas. So let's say as a data scientist, you'll have to write probably 15-20 lines of code to just do that data transformation. Similarly, if we talk about something like choosing your type of machine learning model that you will want to use, so it could be a TensorFlow model, it could be a PyTorch model, it could be an Onyx model. Now, when you're defining your model, you'll first define what the model parameters are. You'll do things like hyperparameter tuning, and that usually again will last in something like 10, 15, 20 lines of code. So as you see that as you're writing all these particular lines of code, there is a lot of scope for reducing some of this boilerplate code that you have to write. And that's what UnionML primarily addresses. That in order to do away with all of this boilerplate code that you have to write, whether it's for training your model, for doing the pre-processing of your data, you can very easily manage that with the help of these ready-to-use decorator functions that do away with that boilerplate code and that layer of abstraction that typically the data scientist will have to write. And you help to reduce that time, and the data scientist can focus primarily on just doing the model evaluation. That's the most important part of any machine learning workflow. So,
Yeah.
Gaurav, would you want to probably explain some of these UnionML decorator functions?
Yes, I'm going to explain you with the help of this dataset. I'll put a picture on this. And so first we are importing and scheduling the libraries. We are using sklearn and pandas for that. So first option is of catching the data. So if we are importing the dataset and the model, and just we are using datasets and test size, and the model is this classifier. That is the main part of the thing, which is UnionML decorator functions. So it's basically the dataset reading and hyperparameters where we are defining the algorithmic nodes. We are using logistic regression here, and the training, which is basically using pandas data frames and predicting and evaluating using just a UnionML function. So what are the names of UnionML model function is? Init is basically just for example we are using init is the init argument used to take class and initialize product in the model, and the training is just as simple as training the function model, suspecting the logics, and then is prediction, which is used to estimate the object features, data frame, and evaluating is basically how is your model performing right now. And the training the model locally is also which is hyperparameters evaluation and matrix, and you have explained the integration.
Sure. And just to kind of add upon to what Gaurav kind of covered in the UnionML model functions, right? So the major idea is that these decorator functions provide you like a plug-and-play kind of a area where, for example, in this MNIST dataset example, we took logistic regression with scikit-learn. Now, you could probably have something like TensorFlow or PyTorch. So instead of your model init function that's for initializing your model, you could simply use or replace the scikit-learn model with TensorFlow or with PyTorch, right? And similarly, when you're training your model, if you want to make some changes to your hyperparameter tuning, you can define that during your training function. And similarly, like let's say if you are doing the data transformation from SQL to your CSV file, you could do that inside of your dataset reader, where it's a decorator function for reading your dataset. So these decorator functions are there for you, so that you can directly just plug and play whatever type of model you want to use, or there will be a decorator function for choosing where do you want to deploy your function. Do you want to deploy it with the help of a fast API, or like let's say with a web framework like Django, Robin or Flask, or you want to do it in a Kubernetes native environment like Flyte or kubeflow. So the idea is that the data scientists do not have to write all of that boilerplate code that they have to typically write. We just have these ready-to-use decorator functions where they just have to define what function that they want to accomplish, and you can very easily just do that with the help of these decorator functions. And coming into the topic of these ecosystem of integrations, so this is what is really the biggest powerhouse for UnionML. So whether it's like defining the type of model integration that you want to use, so whether it's like fast API, Flyte, or you want to deploy your model on something like an S3 bucket, you can very easily do that. Or let's say if you want to define what kind of data store you want to use, or what type of machine learning model you want to use, or like let's say once your model goes into production, you want to continuously evaluate or probably bring in observability for seeing how your model performs in production. So you'll have ecosystems or basically integrations for observability with Prometheus, with Grafana, that you could very easily just integrate and have decorator functions for Prometheus or for Grafana. And as a data scientist, you don't need to know what's going on behind the scenes. Just use the decorator function, define the target for deployment, and very easily use your machine learning models as microservices. So the idea is that as we have microservices in software development, you can create machine learning based microservices, and a data scientist or a machine learning engineer can also create those microservices. And overall, this fits in very well with your entire MLOps architecture. Anything that you would probably want to add?
I think you've covered a lot. So it's basically like removing a headache of putting model into production.
Yeah, that's it.
Okay.